Hi everyone, welcome to join the webinar today with Bin from Alluxio and Adit. We are both open source maintainers for open source project Alluxio, and you're welcome to stay with us for the next 30 minutes, and we will talk about how to burst the Presto and Spark workloads into AWS EMR with no data copies. Followed by that, we would also host a online office hour talking about, we can discuss with you about issues you see, and happy to answer any questions related to Alluxio. So we'll start in a few minutes shortly.
Hello and welcome everyone. My name is Adit Madan and I'm going to co-host today's office hour. For those who are not familiar with the format of an office hour is an opportunity for us to showcase some of our recent work, get some feedback, and answer questions from you. In the first half of the office hour today, I'm going to talk about bursting Presto and Spark workloads into a public cloud like Amazon EMR. And in the second half of the talk, we'll focus more on questions you have for us, be it related to the talk or not. As most of you are familiar, Alluxio is an open source project which came out of UC Berkeley's AMP Lab in about 5 years back. We have a large community such as you, and it's growing at a very rapid pace. Okay, diving into today's talk, I'm going to start with a few common use cases for Alluxio. The common thing among the 3 use cases that I'm going to talk about is that in each situation, Alluxio is typically co-located with your compute application, such as Spark or Presto, and the storage or the data source is on a remote cluster, be it Amazon S3 or other object stores, or a remote HDFS cluster. The first common use case for Alluxio is having Spark and Alluxio run in a complete cloud-only environment in which the data source is an object store, and the compute cluster could be EMR, for example. And I just have Spark there as an example, but you could have other compute frameworks such as Presto, Hadoop, MapReduce, and so on. The second use case, which is common for Alluxio, is the one that is the focus of our talk today, in which I'm going to focus on Presto and Alluxio being deployed in a public cloud, accessing data which is residing on-premise. Now, the public cloud deployment option that I'll focus on for today is Alluxio and Presto in Amazon EMR. But note that this could well be another data center which is hosted within the corporate network, as long as the HDFS cluster is remote and there's a high latency, low bandwidth link between the 2 clusters. All of the assertions that I'm going to make in today's talk are valid to those environments as well. So the middle picture is what we're terming as a hybrid cloud, but note that one end of the hybrid cloud is on-premise in a corporate network, but the other end could be either in a public cloud or in a corporate network. But for consistency throughout this talk, I'm going to refer to the second cluster as being in a public cloud. And the third common scenario for Alluxio is when all clusters, both the compute cluster, which I'm terming as the cluster which has Presto and Alluxio, and the storage cluster are both on-premise. Now, the middle workload is something, like I said, I'll be focusing in the talk for today. One of the reasons we've seen this kind of a migration happening from on-premise to the cloud is that maintaining hardware in the physical hardware in a big corporation is becoming more and more expensive. And what we're seeing is that because of the coupling of compute and storage in these big Hadoop clusters, it's hard to scale storage and compute independently. And also, another thing we've observed is that a large number of these clusters are heavily compute bound. So typically, people are looking to add compute capacity while keeping the storage capacity the same. And also, these compute requirements are heavily bursty. So there could be one job which runs once every 24 hours, but needs double the compute capacity. So instead of buying hardware physically in your data center for just that one job, what you can do is just burst that particular job to the cloud while still having your data on premise. And that's where Alluxio comes in. And in the rest of the talk, I'm going to talk about how we realize this kind of an architecture with Alluxio. Before I dive into how Alluxio does that, a quick primer on Amazon EMR for those who are not familiar with it. EMR is a managed service provided by Amazon, which allows you to deploy compute applications like Spark, storage like HDFS, and other compute applications like Presto and Hive on Amazon EC2 instances. For today's talk, HDFS is not utilized on EMR. Instead, we'll talk about how Spark and Presto and Hive can be used with Alluxio while fetching the data from on-premise infrastructure. Amazon EMR is easy to configure. You can bring up instances in EC2 ephemerally. You can bring up ephemeral clusters, scale clusters up and down as you need based on your workload. Now, Amazon EMR comes with a few core services, the services that I mentioned in the previous slide, like Presto and Spark. But there is a whole set of optional components that can be deployed on top of EMR. And these optional components are deployed on EMR using something called a Bootstrap action. So think of a Bootstrap action as a bash script, which allows you to install optional components on two kinds of nodes in EMR. One is the master node and one is the worker nodes. So Alluxio utilizes this mechanism to deploy Alluxio on Amazon EMR. The Alluxio Bootstrap action is available on our website. I'll point you to some resources at the end of the talk in case you want to get started by using that. But the Bootstrap action is something that you can use to deploy Alluxio along with your compute. And like I mentioned before, the commonality in the different use cases for Alluxio is that Alluxio is typically co-located with the compute infrastructure. So as the compute infrastructure is deployed on Amazon EMR, we also typically want Alluxio to be deployed on the same cluster. Okay, so the architecture for today's talk looks something like this. The block on the left I have is your on-premise infrastructure. It is a data center with different services. The two components that we care about the most for today's talk is Hive and Hadoop HDFS. Hive is the source of the metadata, structured table definitions, and Hadoop is the data source, which is storing binary data in files. There is going to be, in typical scenarios, there is a lot of compute resources co-located with HDFS, and the reason why people burst into the cloud would be when the compute resources on the cloud is not enough to either meet the SLAs that people have, or in general, it's overloading the HDFS name node, and the storage infrastructure is not able to serve the requests for the compute cluster. Now, once the decision has been made to migrate some of the workloads to the public cloud, when it comes to the actual data, there are several challenges which make this architecture hard to realize. And that's exactly where Alluxio comes in. So if you look at this picture without Alluxio, you have on the right side, you have an Amazon EMR cluster, you have the compute ready to start running queries. But where does the compute cluster get the data from? Now, there are a couple of alternatives for this. The first alternative is that the compute cluster on the cloud continues to read data which is on-premise on the left-hand side. The problem with this is that typically the network infrastructure which is connecting the two clusters, the public cloud cluster on the right and the data center on the left, is not sufficient to give you the performance that you need. So you have, like I mentioned, you have a low bandwidth and a high latency link between the two clusters, which could amount to increasing the query times, the execution times for your workloads from 1 to 10x. Now, this is where Alluxio comes in. So Alluxio kind of sits between the compute on the right-hand side and the data on the left-hand side. And Alluxio acts as a cache for metadata and data. And I'll elaborate on that further in the next few slides. Now, the alternative to accessing data remotely is that you could also migrate data from your data center to the cloud. And then all future workloads would read only from the copy that you have in the cloud. And the copy in the cloud could be maintained in cheap object storage or other storage resources you have on the public cloud side. Now, the problem with that approach is that there are existing pipelines on the on-premise side, which is ingesting or updating new data into the HDFS cluster. Now, as soon as you migrate the data to the cloud and there is some modification on the on-premise side, that data that you're querying in the cloud is already stale. And the second problem with this approach is that once you copy the data, and let's say you miss some data that you were planning on querying, you still don't have that data available. Then you will go ask an admin that, okay, this is the data I need. Then you'll have to wait for all that data to be copied. So with Alluxio, what happens is that data is made accessible immediately. As soon as you have the Amazon cluster spun up, even if it's ephemeral, as soon as the cluster on the right is spun up, data is available for querying immediately. Alluxio does not have to wait for the data to be copied to the cluster on the right first for data to be accessible, but instead data is accessed, copied on demand from the cluster on the left to the right. So just to enumerate the two benefits over the second option that we had without Alluxio, the first is that data can be, you don't have to pre-identify data sets which you need to query on the right-hand side. And the second is that data updates on the left-hand side of the picture are transparent to the user. You don't have to do any manual work, and Alluxio just fetches that. I'm going to elaborate on these benefits in the next few slides. Now, the first thing that would happen for you to be able to query data in Amazon EMR is once you have the cluster up in EMR, like I said, Presto and Spark could be the two applications that you care most about, and Alluxio is co-deployed with both of them in Amazon EMR. Alluxio uses something called HDFS iNotify, which is a notification scheme, a notification mechanism in HDFS, and Alluxio is made aware of any mutations on HDFS, and it's sent a stream of such notifications, which Alluxio then uses to make sure that its namespace is in sync with HDFS. So for those familiar with Alluxio, Alluxio uses a concept called a mount point, and a mount point is just saying that, okay, this portion of the Alluxio namespace maps to this portion of the understore, and understore in this example is Hadoop HDFS. In the picture that I have, you can see that a file at path 1 has some old data in it, and it's mutated to the same name but different contents of that data. Now, such a mutation would be an event that HDFS would send to Alluxio using the iNotify mechanism. And once you query these files through Presto or Spark, it is made available within a few seconds. And the default interval for this is about 30 seconds is when Alluxio polls HDFS to receive events like this. So the concept of metadata locality influences our architecture in a couple of ways. The first is what I mentioned earlier, that any updates on the right-hand side in HDFS are picked up by Alluxio almost immediately. And the second is that the latency for metadata operations is no longer from your compute application like Presto to your on-premise HDFS cluster, but instead the latency for metadata operations is Presto to the Alluxio master, which is co-located, and this latency is much smaller than the latency you would see when you query Presto onto the HDFS main node. Now, the second pillar to realize this architecture is data locality and caching that Alluxio provides. Now, Alluxio and EMR can manage different forms of storage. It could be memory such as RAM or other disk resources such as SSDs. When you start reading data from HDFS, data is fetched on demand from HDFS and loaded into Alluxio, and subsequent accesses for the same data are then served from Alluxio. This makes the latency to data access much smaller, and also if you're running into bandwidth limitations, hitting your remote data center frequently, those problems are also eliminated by using Alluxio. The third pillar in realizing this architecture is that what happens to structured table definitions? The two bullets that I talked about previously is talking about data stored in files. But as someone who's issuing SQL queries, the thing that you care most about is tables. And typically in the architecture that I showed before, or the situation before you're using the public cloud, in your on-premise infrastructure, you would have Hive as the meta store, which is storing the table definitions, and HDFS is the source of the data. Now, the tables which are defined in Hive are pointing to HDFS locations. And once you launch the cluster in the public cloud, how is Presto identifying the metadata for these same tables which were previously defined on HDFS? So once you launch the cluster in EMR, the way to configure the system is that you would create a Presto catalog in EMR, which is pointing to the Hive metastore on premises. Note that the Hive metastore on premises have HDFS as the table locations. Now, there is a feature in Alluxio called transparent URI, which allows Alluxio to intercept any calls from Presto and forward it to Alluxio. So when you're querying something in the public cloud and you see that the data location is HDFS, instead of going to remote HDFS, and by remote HDFS, I mean the HDFS which is not on the public cloud, but the HDFS which is on premises, Alluxio is able to intercept all these calls from Presto and forward it to Alluxio instead. And since HDFS is mounted into Alluxio transparently, and Alluxio is able to serve all requests to HDFS. Instead of, if the data was not present in Alluxio, Alluxio would simply on-demand copy data from HDFS, and metadata is an asynchronous process, metadata synchronization between Alluxio and HDFS, like I talked about before. So the gist of after the three pillars that I described is that as soon as you have the query up, as soon as you have the cluster up in Amazon EMR, and Alluxio has synced the metadata from on-premise to the public cloud, you are ready to start querying. The first few accesses are going to see data latency, but the metadata latency is eliminated, and the subsequent calls for the same data is going to access Alluxio only and not go to remote HDFS, which saves you the data latency and the data bandwidth as well. Okay, so those are the three pillars, like I said, to realize the architecture. Now that we have the main description of what that is, I'm going to share some benchmarking results that we ran a few months back. And the environment that I used for benchmarking is two Amazon clusters, two clusters in EMR, but in two different regions. So the cluster on the right is depicting our actual public cloud cluster, which is in US West. It has EMR, it has Presto, which is in a certain VPC. And the cluster on the left is kind of mocking your on-premise infrastructure. The reason for launching it in a different environment is to create a high latency link between the two clusters, which would typically be the case when you're connecting a public cloud cluster to your corporate network. And similar to what I had described before, Hive is the meta source and Hadoop HDFS is your data source. We use something called VPC pairing in Amazon as the network link between the two clusters. VPC pairing has a very high bandwidth as it goes over the AWS backbone network. But the latency that we have in this picture is about 175 milliseconds round trip time between the two clusters, between the public cloud cluster and the mock for the on-premise cluster. We used about 10 instances for the workers, one for the master in both these clusters. The cluster on the left had the TPC-DS data pre-populated. Tables were created only on the left-hand side of the picture, pointing to HDFS locations. As soon as we spun up the cluster on the right, which was pre-configured with Alluxio and Presto, we could start issuing queries, reading data and metadata from the left-hand side of the picture. So moving on to the results of the benchmark, what we saw was, so the annotations that I have in this picture is Alluxio warm and HDFS remote. HDFS remote denotes the case in which, like I said before, your cluster is, the compute cluster in the public cloud is fetching data from the on-premise cluster. So that's the case that we refer to as HDFS remote. Now, when you're reading data through Alluxio, there are two cases. One is Alluxio cold and one is Alluxio warm. Alluxio cold is denoting the case in which the data itself has not been read into Alluxio yet. The first access by a query which is targeting that data would read the data into Alluxio, and subsequent accesses would go through Alluxio. The first case in which data is not present in Alluxio, that is Alluxio cold, and the second case in which data is already in Alluxio is called Alluxio warm. Now, the case in which Alluxio is cold, that case we see performance similar but a little better than HDFS remote. For a full benchmark results, I'll point you to a white paper towards the end, and you can go through the results. But focusing on the case in which data is already present in Alluxio, we see on average about 3.5 times the performance gain over queries in HDFS. Now, the scale factor that we used for these experiments was 1000. And the white paper that I talked about before has more information about these experiments. But on average, we saw about 3 across the entire set of 100 queries, about 3x. And the 4 bars on the right is showing you the query performance by the different classes that we have. So for the reporting class, the benefit that we saw on average was a little less than 3x. For interactive, it was a little more than 3x, and so on for the deep analytics and the uncategorized class. So uncategorized is just queries which do not belong to either reporting, interactive, or deep analytics. The maximum performance gain that we saw across all of the queries was for query 9, in which we saw about a 7x difference in reading the data through Alluxio versus reading the data from HDFS directly. And the HDFS is the HDFS on-premise. Reads on all cases are happening on the cluster on the right, in the picture before, which is the Alluxio cluster in the public cloud. The maximum improvement by class was for each of the categories is shown there. For query 27, we saw about 3x improvement of the Alluxio warm case over HDFS. For interactive, it was about 4x, and similarly for deep analytics, it was about 4x a performance benefit when you access data from Alluxio. Now, note that you don't have to rerun the same query multiple times to see these benefits. The usual case is that once you run a query, it's going to prefetch certain data into Alluxio, and the same data is going to be used by subsequent queries, even if it's a different query. The best case is where the exact same data, best case for Alluxio is when the exact same data is accessed twice, which also happens. But the more common case in which is that there is overlap between the data that is being accessed across these different queries, and that data is fetched in Alluxio. Note that I haven't talked about certain mechanisms in Alluxio which could be used to warm up the cache in Alluxio. So you don't have to warm up the cache in Alluxio by running queries itself. So let's say if there is a period of inactivity on the cluster, you could schedule jobs to load data asynchronously from your on-premise cluster into Alluxio. And all subsequent accesses, even if it's the first access by a query, is going to see these performance benefits that we talked about, just because the asynchronous job had fetched the data and made it warm for you. Okay, so that's all I had to share on the benchmarking and realizing the architecture for accessing data in a public cloud using Presto or Spark or other applications and fetching data from your on-premise Hive and HDFS environment. Even though I focused on Presto for this talk, we see similar performance gains. Actually, we see better performance gains with Spark due to the data access pattern that we see. So the max performance gain that we saw for Presto was about 7x, since Presto is optimized for remote storage. Spark, which is less optimized for remote storage, we see performance gains ranging from 10x all the way to 40x over Spark. So even though I focused on Presto, I focused on Presto because Presto seems to be more optimized for remote storage, and we see more people use Presto than Spark when querying data which is remote. The first resource that I have on this page is the white paper that I mentioned, which has a detailed report, detailed benchmarking report, a strategy to realize this architecture and the architecture itself. Okay, so thanks everyone for listening into the first half of this talk. Now I'm going to jump onto Slack and answer some of your questions. So the first question that someone had, which been responded to, is that we will share a recording of this, and the slides for the talk will go up on our website. So all the resources that I linked to, you'll be able to click on that using the slides that we have posted to our website. Okay, so the first question on Slack is, if data has not been cached in memory in public cloud, when a job comes, does Alluxio copy the data to the public cloud? Yes, so I think I mentioned that towards the end of my talk. There are two ways for data to be copied to the public cloud. One is when the job comes in itself. So the first run of the job would see some latency in the data being copied from on-premise to Alluxio. Note that Alluxio doesn't have to be configured to use memory in the public cloud. It could use SSDs as well. And the second way is when you use something in Alluxio called a distributed load. A distributed load is a command line utility that we have, and you can schedule that utility to asynchronously load the data from on-premise into the public cluster. Now, the benefit of the second approach is that even the first run of your job doesn't have to witness the latency of copying the data into the public cloud synchronously during the job itself. So the second question is, does the initial data pool take time to cache in Alluxio? Yes, the first data pull takes time to cache in Alluxio. But what I would like to highlight in that scenario is that even though the first data pull takes time, Alluxio still has the metadata worm. And I'd like to highlight the metadata component in all of this, because a significant portion of the execution time for a query is on metadata operations. And even though you are pulling the data during the query itself, you still benefit from having the metadata in Alluxio. And this would be also, like I said, it would be only witnessed by the first query, which is pulling the data in, and all subsequent queries which pull the data in would not witness this latency. Okay, so the next question that we have is, can we have more than one under FS at any point of time? Yes, so Alluxio can have many under FS under storage systems at the same point in time. One scenario that is relevant to the architecture that we talked about today is that Alluxio can be configured to have HDFS and cloud storage as an under FS at the same point. Now, HDFS is your original source of data, which is on-premise, but you could also use cloud storage as an under FS for Alluxio. Now, the reason for using the latter is that in some use cases, we've seen that people would like to migrate data from on-premise to the public cloud. And Alluxio allows you to set certain policies which allow you to migrate data from your on-premise infrastructure to the cloud infrastructure on demand. So you could set a policy like, if the data on-premise is older than 10 days, I would now like to migrate this data from on-premise into the public cloud. And this kind of a situation is actually mounting more than one mount points into Alluxio. So the next question is, if the data set is too large to load into the cache cluster, how does Alluxio deal with that? Evict pages to local disk or on public cloud? So the way Alluxio deals with that is that Alluxio can be configured in certain ways. So we could have multiple tiers for Alluxio. So the first tier for Alluxio, if you're using memory for Alluxio, the first tier would typically be memory, which would contain the warmest data in Alluxio, and you could also have SSDs. Now, once the data does not fit completely, the data that you've accessed does not fit completely in Alluxio, Alluxio would either move it between the tiers that it's managing on the public cloud itself, or it would evict data from the public cloud, and it'll have to re-access the data from the on-premise environment. So you could think of, if memory is your primary tier, SSD is your secondary tier, you could consider the on-premise HDFS as your tertiary tier. So if you have data in memory and we run out of memory, that data would be evicted from memory and go into SSD. And if we run out of SSD space, that data would be evicted from SSDs. And the next access is going to fetch the data from your on-premise HDFS. Is there, the next question is there a use case where Alluxio is installed in a separated cluster and several other EMR clusters use the Alluxio cluster as a data source? Yeah, so that's a very good question. So there is a use case for that. And we have seen people have standalone Alluxio deployments in the public cloud and connect different EMR instances to the Alluxio cluster, which is not co-located with EMR. And the Alluxio cluster is kind of acting as the cache for your on-premise data. And the benefit of this is that the lifetime of your Alluxio cluster can be disassociated with the lifetime of the EMR cluster or the compute cluster instances itself. So you could, let's say, you could have a smaller instance, a smaller cluster of Alluxio, which maintains the data and metadata warm while you spin EMR clusters up and down. So this is kind of eliminating the the issues with some of the previous questions that we saw was that what happens when Alluxio does not have the data warm? And it has to go back to the on-premise environment. So the benefit of this is that you could have a long-running Alluxio cluster, but spin up EMR clusters on demand, and your data would still be accessed from Alluxio as and when needed. So the next question I have is how Alluxio reduce latency caused by network bandwidth as we start Spark. It will wait for Alluxio to cache the data. So let me make sure I understand this question. Okay, so on the network bandwidth side, I'm not sure I completely understand this question, but as I understand it, once you start the cluster with Spark in the public cloud and you use Alluxio to cache data, only the first instance of the query is going to go to your remote HDFS and fetch the data into Alluxio. And since there is reuse of data across different queries or different workloads that you're running, Alluxio will only go to your remote HDFS for the first query. And since the amount of data you're fetching from your on-premise environment is reduced, the network bandwidth that you're utilized is also reduced in that case. Okay, so the next question we have is, what is the flushing policy? What happens if data scan removes important key data set required to be in Alluxio? Can we store any object based on our need without being flushed? Yes, so for this, that's a very good question. What we have in Alluxio, a feature called pinning. And what pinning does is that if there are certain data sets that you have pre-identified as being important, what you can do is that you can pin these data sets in Alluxio. And what that does is that when Alluxio wants to identify data that is data which is a candidate for eviction, it would not not evict data which has been pinned. So essentially what this is doing is that by identifying these important data sets using a pin, the important data sets will stay warm, will stay cached in Alluxio, whereas data sets which are not important can be evicted, and on subsequent accesses we'll go back to the on-premise infrastructure and fetch that. So the next question that we have is how much change would be required at the application side? So we have designed Alluxio in a way to make it transparent to the user to switch from using S3 or HDFS to start using Alluxio now. Alluxio has an HDFS compatible API, and using the feature that I talked about before called transparent URI, the changes that you need is only going to be on the configuration side, but the actual application code does not need to change at all. So you don't even need to change the location of the data that you're pointing to in the application, but instead, by simple configuration changes on the compute side, you would be able to access the data. And the thing I would like to highlight there is that the configuration changes that you need on the on-premise side is almost nothing. So there are situations in which you would need changes, but that's also very minimal, and it's only configuration changes that you need. Okay, so the next question is, what kind of security does Alluxio have? For example, if EMR has Kerberos enabled, how will Alluxio deal with that security? So that's a very good question. So Alluxio has different kinds of security integrations. Alluxio on EMR can be enabled to use Kerberos along with your EMR cluster. And Alluxio already supports cross-realm integration. So let's say a typical security architecture for what I talked about before is that you have an EMR cluster in the cloud, and you have a KDC in the cloud, which is pointing to your Microsoft Active Directory on-premise. Now, in this infrastructure, your KDC in the cloud has been configured with cross-run trust, trusting the authentication by the Microsoft Active Directory on-premise. And Alluxio can plug into all of these components, and Alluxio can be configured with cross-run authentication, and you can continue to use your EMR cluster with Kerberos authentication, even when the data is being accessed from Alluxio. Now, that said, the caveat there is that even though all of the things that I said for this is possible today, it's not trivial to configure without an understanding of what Alluxio is. So to address this specific problem, starting with Alluxio 2.3, we are planning on making public Terraform templates, which encapsulate the Bootstrap action that I talked about before, and will allow you to configure your compute cluster as a whole in the public cloud, connecting to your on-premise infrastructure, or let's say even in cases when you want to have your data source in the public cloud. Making this configuration and deployment much easier is the focus that we have for Alluxio 2.3, and we'll make available Terraform templates. But coming back to the question, we have integrations with on-prem components like Cloudera Sentry, and we have ACLs and FACLs, and so you could continue to use the security that you're used to for your on-premise infrastructure, even when your compute is in the public cloud. The next question that we have is, do you provide any environment to evaluate Alluxio along with EMR? So we have something called, so we have the Bootstrap action available as of now. We have a quick start guide in the works for Alluxio and EMR, which would allow you to do exactly the benchmarks that would allow you to reproduce the benchmark that I presented today. So what that, so it's based on Terraform, and what that quick start would do is that it would launch 2 clusters in EMR, one acting as a mock for your on-prem infrastructure, one acting as the EMR cluster in the public cloud itself. And you'll be able to evaluate different benefits of Alluxio for your specific queries or your specific workloads using that environment. So unfortunately, that's not public as of now, but it is definitely on the roadmap for our 4.2.3, and hopefully it's going to be made public much sooner than that, within a couple of weeks, since we already have all of the data. We have everything available for it to be made public. Okay, so the last question that I see on Slack is that, let's say data is in S3 and we use Spark EMR. Does it make sense to involve Alluxio here? How will it benefit? So in the case in which we have data in S3 itself, the kind of performance, the kind of benefits that you see from Alluxio would not, in terms of raw performance itself, would not be similar to what I described right now. So it won't be like 7x or so. Actually, with Spark we see a lot bigger one. So it won't be like 40x performance benefit in some cases, or it won't be like a 10x performance benefit. But the performance in itself will be smaller, since the latency from an Amazon cluster to an S3 storage environment is not going to be high. But in my experience, what you'll see in terms of benefits is more, it's going to be consistent performance. So you'll be able to meet your SLAs, and the performance will not be variable as compared to S3. So we have certain users, which maybe Bin can elaborate about that a little later, is that we have people using Alluxio in EMR, reading data from S3, but the kind of benefits that they are looking for is not the raw performance number itself. So they're more looking for SLA gains in those scenarios.
Yes, this has been Timmy here. Yeah, we see users using Alluxio with the pure single cloud stack, sometimes to improve the performance SLA, in order to meet their customers' requirement, say running Presto to return queries in sub-seconds or something like that. With S3, you may hit some issues like once a while or due to some other reasons out of your control. But with Alluxio, this can just really minimize the risk or to make everything in your control, because S3 otherwise is a separate service.
Thanks, Ben. Moving on to the next question that we have, it says, do you have any requirements for authentication between Presto and Alluxio? So depending on the security requirements that you have, you could use different authentication modes. You could use an authentication mode called simple, or you could use Kerberos as the authentication between Presto and Alluxio. So, or you could turn it off. So like I said, it's very configurable. Depending on your needs, we can set up authentication accordingly. The next question that we have is, even if we test and get more results with these use cases, does this statement hold true? With Alluxio on public cloud and on-prem data, network latency will be lower than latency with computation at on-prem data locality. So I wouldn't say it's going to be lower. So with Alluxio, the latency that you see, the network latency that you see between your Presto application and Alluxio is going to be similar to the latency that you see when your compute was on-premise itself with the data locality case. So but the benefit of moving to a public cloud is that you could choose the framework that is right for your job. So let's say if you don't have a Presto infrastructure on premise and you want to start using Presto, you don't have to provision an entire separate cluster on premise to use Presto So you could just spin up a few instances, which is managed using EMR or other deployment frameworks, and you can still continue to use the data. And so it's not going to be lower, it's going to be similar. And the other benefit that I was going to talk about was that you could provision better instances, and better, I mean newer instances in the cloud. So instead, by having the physical infrastructure on premise, that doesn't really give you the flexibility of provisioning powerful instances on demand. So that's the other benefit that you could get. And that could potentially bring the network latency down as well, like if you have powerful instances with a good networking stack. But in general, I would say if the instances on premise are similar to the instances in the public cloud, the network latency that you would see is going to be similar if everything was local in that case. Okay, so I don't see any more questions on Slack, but we could pause for a little longer. Or Ben, if you wanted to comment about something else, we can do that right now as well.
No, I think this is great. We see a lot of questions, and to my surprise, more than I expected, much more than I expected. Yeah, but we can be here for another 5 to 10 minutes. Anything related to today's topic, or even not related to today's topic. If you see any issues, you're entering, you encounter some errors, you don't know how to configure Alluxio, we're here to help. Yeah, so that's the purpose of having office hour.
Also, guys, if you have any feedback, that's also welcome at this moment, not just questions, but any feedback, or if anything you can tell us about how this fits your use case, you could also comment about that.
Yeah, so since you are still here, like maybe Adit, you can talk about, is there anything we're doing like for the next release 2.3, like that might be exciting to users?
Yeah, sure, Ben. So like I talked about before, a huge focus for 2.3 for us is to make the story that we presented in these slides very easy for use to people. So one of the things we are doing is we are improving our documentation, and we are also providing Terraform templates for people to realize this without any knowledge of Alluxio. And the second thing that we're doing in these scenarios is that we are also experimenting a lot more with different combinations of latencies or bandwidth between the clusters. So if you come to us with a requirement, we would be able to tell you exactly that is Alluxio a good fit for you or not. And depending on your data set sizes, the number of files that you're using, we'll be able to tell you exactly if this is a good fit for you. On that note, something I would like to say is that if you're running a toy data set, which let's say has a few hundreds of files, you may not see the same kind of performance benefits. But if your files are in the millions, or like a few thousand, so those are scenarios in which you will see more benefits from it. And like depending on the data that you have available on a cluster, so there are many factors which would influence the performance gain that you see with the Alluxio. Ben, was that did that kind of answer your question? I know we have a lot of things. We have a lot of things going on, but I just wanted to touch upon a few things which are relevant to the talk today.
Yeah, I think definitely that's one part of the work we're doing. But meanwhile, we also have a lot of internal efforts to essentially basically improve the robustness and also the efficiency for the software, and to further like we see like people get a lot of we get a lot of feedbacks from users regarding different cases. We try to cover more corner cases and to reduce some overhead. We introduce like some tech debt. Essentially, we're trying in the 2.3 release. I would say like this is going to be a more robust and more performed version. And actually, we have been doing on this effort for already one release. 2.2 is mostly a very stabilized version on top of 2.0. 2.0, we introduced a lot of new features, embedded journal, we introduced a job service, and a lot of different new features. And we're trying to, based on these new features, stabilize and make it very performed. That has been the theme for a while. Oh, actually, there's one more question.
Oh, yeah.
From Slack.
I see the next question that we have on Slack is that what kind of enterprise support is available for Alluxio? So Alluxio has two editions. One is what we term as the community edition, which is free to use, and that does not come with enterprise support. But we also have an enterprise edition, which comes with some specific enterprise-only features and also support. So I would suggest that you go on to our website, alluxio.io, and you will be able to compare the differences between the two editions that we have. But yeah, we do have support available, and depending on the customer, we have different kinds of SLAs for the support that we provide.
Yeah, so kind of for advertisement for future online events, we will be very heavy in hosting online meetups or office hours. So we're trying out experimenting different forms of office hours. For ones like this, we have a pre-selected topic. So there will be a short presentation associated, and the purpose is to answer people have certain questions. We're also trying out a different format that we don't have any pre-selected topic, and I will be there hosting this kind of like open office hour. Anyone can join and ask me questions. So in addition to curating the questions on Slack channel, you will see my name's quite often there. I will also try to using Zoom or some similar technology to chat face-to-face and try to use this bulk of time to speed up this kind of like debugging or discussion sessions. So in addition to office hours, we also collaborate with users to evangelize to share their use cases a lot. Next, I think next week, next week, I'm actually hosting another online meetup talk with Facebook developers who are maintainers for Presto. And we're talking about the latest effort in collaborating to further reduce the latency for Presto workloads. And one of the approach we're attacking here is to introduce another called Alluxio client-side caching technology into Presto. So I'm just working with Facebook engineers to merge this code back to Facebook code base, to the Presto code base. Yeah. So we will talk about that on May 7th.
Great, thanks a lot, Ben. I'm excited to hear about the Presto integration and the work at Facebook.
Cool. Thank you a lot. Thank you everyone for joining us. And I had a very great time here and hope you also feel the same way. And as I mentioned before, the video will be recorded. The video is recorded and it will be available for playback very soon. Yeah, thank you. Thank you, Adit.
Thanks. Stay safe, guys.